In addition to using optimization to find the maximum or minimum values in a real-life situation, optimization can be used to find the maximum or minimum area of two bounded algebraic expressions. For example, in this problem, we are finding the maximum area of a rectangle that can be inscribed in the parabola y equals 1 minus x squared. As always, you would need to draw a picture to get an idea of what the problem is asking for. With this problem, the parabola is 1 minus x squared with the y-intercept at 1 and the roots at 1. Inside there is a rectangle, and we are trying to find the maximum possible area of that rectangle. Step number 2, as always, is to come up with the algebraic expression to represent what we are solving. In this situation, the area can be described as area equals 2xy. Thirdly, we need to find the secondary relationships so that we can solve for the equation with a single variable rather than multiple variables. In this case, using the actual function of the parabola y equals 1 minus x squared is quite appropriate. From there on, we can use that secondary relationship and plug it back into the original algebraic expression. So we will be plugging in y equals 1 minus x squared into the y from area equals 2xy. In doing so, you would get a equals 2x minus 2x to the third. As with any calculus or optimization or derivative problem, you would need to take the derivative. In this case, the derivative of the area is 2 minus 6x squared. Finally, to find the maximum or minimum value or area, you would need to find the critical points. In order to find the critical points, you would need to set the derivative equal to 0. In this case, the derivative is 2 minus 6x squared. You can pull out the 2, factor out the 2, set that equal to 0, and set the other pair of expressions, 1 minus 3x squared, also to equal to 0. When you set 2 equal to 0, you get 2 equals 0, and that's impossible, so we will disregard that. On the other hand, when you do 1 minus 3x squared equals 0, you eventually come up with positive or negative root 3 over 3. At this point, we cannot determine whether the positive or the negative version of the root is the maximum area for the inscribed expressions. In order to find the extremas, we need to have a table that compares the x values to the prime values of the function. After using various numbers, various values to compare whether the expression comes out as positive or negative, you can see that values greater than root 3 over 3 came out to be negative, and values that were between the two numbers came out to be positive, resulting in a maximum for the root 3 over 3, the positive version of what we had. Before we get on to the statement, we would need to find out what the statement, what the question was asking, and in this case it was asking for the area, not the x value. So in order to find the area, we would need to take this a step further and plug the x back into the y and get the y value. And then because area was earlier defined as 2xy, we can plug the x and the y back into that equation and finally have an answer. So the statement for this question is the maximum area of a rectangle that can be inscribed in the parabola y equals 1 minus x squared is 2 root 3 over 9 units squared. Always be sure to use the units, and in this situation units were not clearly defined, so just put units squared. Thank you very much.